Okay, so today I'm going to go over 12, 13, and 14. It might be in 2 videos. It might be in 1. We'll see how fast I can go through this. So in your worksheet, like I said, 12, 13, and 14 are ones that I want to make sure I go through so you see what they're like before you take this wonderful test. Okay? So the average depth of the water at the end of a dock is 6 feet. So when we say average, we're talking about that midline. It's the middle value. And so the depth of the water will vary 2 feet in both directions. That means it can be 2 feet higher and it's going to go 2 feet lower. So that tells me if I want to draw this graph, because it says sketch a graph, and if we make the y-axis the depth, that means that at 6 feet, here, 6 feet, that's like the midline. So you can have that go across. And going 2 above and 2 below that, 6 plus 2 would be 8, and 6 minus 2 might be 4. So this may not look very symmetrical here, but we'll go with it. Okay. Suppose there is high tide at 4 a.m. So high tide would mean that you have your max at 4. And then it goes from low to high every 6 hours. Okay, so assuming it's going from low to high in 6 hours, it'll go back from high to low in another 6 hours. Okay, so we're going to also allow t equals 4 to correspond with 4 a.m. For this, we will assume that we're going to use military time so we don't start over again. So if I do this across the bottom, so 1, 2, 3, here's 4. And then I know in 6 hours, it's going to be at the minimum. So 4, 5, 6, 7, 8, 9, 10. So at 4 hours, it's at the max. Let me change my color here and make it a little bit easier. So 4, it's at the max. 10, it's at the minimum. So if I keep going here, it'll be back up at the max at 6 in 6 more hours. So that's 10, 11, 12, 13, 14, 15, 16. It'll be back up at the maximum. Okay, so that's what we have to look at so far. To help us find where our function crosses at the midline, what we want to do is figure out what is halfway between 4 and 10. Well, I know the difference between 4 and 10 is 6, so half of that is 3. So I know 3 hours after 4 o'clock, so at 7, it'll be at the midline. And then same thing here from 10 to 16, that's going to be 6 hours. So if I add 3, 1, 2, 3, it'll be at the midline. So your function looks something like that. Okay. Notice here I did not tell you whether you use sine or cosine. So since we know the max value, I would honestly do cosine, do the easier one. You can figure out quite easily. You could calculate your sine and know that, oh, it'll be back at the midline 3 hours before 4 a.m., which would mean it would be at 1 a.m. And that looks like sine, so you have that shift of 1. But for this, I would suggest using cosine, just my suggestion. I have enough information to come up with the amplitude, period, so calculating B, the phase shift, and any vertical shifts here. Okay, so the amplitude, remember, is A. That's the distance from this midline to the max. So if it's at 6, to go up to the max, that would be 2. The period is how long it will take to repeat itself. So if it was at 4, repeats itself at 16. 16 minus that 4, that difference, is 12. So to calculate b, I would take 2 pi, divide it by my period, and that is 12. And I get pi over 6. Okay. From there, I can figure out the phase shift. So phase shift, remember, is your c over b. And so if we're looking at cosine, we find our max. I would find the one closest to the y-axis in my graph here, staying positive. And so that happens at a time of 4. So the general parent function graph of cosine, we would have this max at 0. So horizontally, it would be a t-value of 0 times 0. But we see a 4-hour shift, so our phase shift, that distance from the y-axis to that max horizontal distance, is 4. And then the vertical shift, which is represented by d, we look at the midline. And the midline normally would be on the x-axis, so on this horizontal line here, which would be a vertical value of 0. So that'd be a y value of 0. However, on the midline, all of the points on the midline have a y value of 6. Then looking at my notes, I know A, I know B, I know C over B, and I know D. So I fill it in, and our equation here, our function, would be y equals 2 cosine of pi over 6 times x minus 4. And all of that will be added with 6. Okay, so that is number 12. Moving on to try to get 13 here. So scientists believe that the average temperatures at various places on Earth vary from cooler to warmer over thousands of years of gradual climate change. Okay, suppose that at one place the highest average temperature is 80 degrees and the lowest is 60 degrees. So already I can see on this graph, I can calculate that we have a highest temperature value of 80. And I'm going to put the squiggle in case you don't know the squiggle. That's jumping over, so I don't have to make a huge graph. I can just jump up to 60. I can zoom in on the parts I want. So we have a max of 80 degrees and a minimum of 60 degrees. Also suppose that the time it takes to go from high to low is 20,000 years. In the year 2000, the average temperature is at a high point of 80 degrees. So right here I can say this is 2000 and it's at the high. And we're assuming it's sinusoidally, so that means it's sine or cosine. It's going to repeat itself as a wave. And so first we want to sketch a graph and find an equation that models this. And then, find an equation that models the temperature as a function of time in years. Okay? So what I would suggest is that you could either leave this as years and say, hey, years is being represented by x. If you want to, you could change x and change that to y, or change it to t, sorry. You have this degrees, y. Okay. So to figure out what we put across the bottom, we know going from high to low averages would be 20,000 years. So it's at a high at 2,000 years. I have to add 20,000 to that. And so that would be 22,000. And that's the low. That's the low. Okay. And then 20,000 years after that, since it's constantly moving, constantly repeating here, that would be at 42,000. It's going to go back up to the max. Okay. But we also would love to have this midline that'll help us out a lot. So halfway between 80 and 60 happens to be 70. So we have this lovely, lovely midline here. So it's halfway between our max and our min, which means our amplitude is 10, because from 70 to 80 is 10. Now we need to have those points on the graph. So if it's going from the max to the min in 20,000 years, that means halfway between that, it will be, so in years, half as many years in between, it'll be halfway between 80 degrees and 60 degrees. So half of 20,000 divided by 2 happens to be 10,000. So at 12,000 years, I'm on the midline. And then if I add 10,000, because that's halfway between this 20,000 here, I would be at 32,000, and that's when I'm at the midline. Let me draw this in a different color really quick. So I've got this function here. Okay. So we already said the amplitude was 10. And looking at the period, if it starts at 2,000 and we see it ends at 42,000, the period, if I take 42,000 minus the 2,000, you should get 40,000 years. Which means that to find b, when I take 2 pi and divide it by 40,000, that's going to be pi over 20,000. Just leave it as the fraction. It will not hurt anything to do so. Okay. From here, we now need to think of the phase shift, which is c over b. And so normally, remember, cosine would start on the y-axis. It is not on the y-axis. It was actually shifted to the right 2,000 years. So that's 2,000. And then the last part is the vertical shift, which is d. And so we look at the midline and we see how far above or below the x-axis did the midline shift. And hopefully you notice that the midline, this dotted line, moved from the x-axis up 70. So when I put this all together, let me write this so it stands out a little bit more. Our equation would be y equals the amplitude 10. Let me pause. For this one, since again we start at the max, I would suggest using cosine since that's how we decided our phase shift. We saw, oh, it's the max that we're starting with. Otherwise, you would have to figure out either going to the left, the negative value for a shift for sine, or start at this 32,000 for sine, since that is when sine is increasing. So I would suggest using cosine. Like how I did that, sorry. I would suggest you use cosine. So here, y equals 10 cosine of pi over 20,000 times x minus 2,000, and I'm about to go off the screen. And then you would add 70. I'm sorry about that. I'll rewrite it down here for you. There you go.